So, and you know this, if you're a teen, then you wear jeans. Give me a made-up name. Jay. Okay, well, we'll say if you meet a guy named Jay and you see he's a teenager, you can assume then Jay wears jeans. We're applying it to a specific person of deductive reasoning. Deductive reasoning. Let me give you a visual. Have your reference booklet opened to where we last left off, which was right at this. You should have a paper clip sitting there, folks. All right, now we're going to go right underneath. Okay? Hands up. Observation, you take it into your brain and you have comment. That's inductive reasoning. Now go like this, say, aha. Point to somebody. Okay, you take your aha and you apply it to a specific situation. Right here, folks. Inductive, multiple observation, you take it in and you come to a general truth. If you are a teen, then you wear jeans. It's in your reference booklet. Megan, can you help, please? Oh, I'm sorry, Charles, you weren't here the other day. Okay, ladies, can you grab it from Charles and just find his place, please? It'll go faster there. Then, if you take that general truth, take your aha, and apply it to a specific, star the word specific. And okay, there were two other logic laws from last night. If you have a conditional if, P, then Q. You guys hear this one all the time. It's called law of transitive. It's also known as a syllogism. Great word, fancy word for something you're already intimately familiar with. And you can save money. If you save money, then buy a car. Therefore, if you get a job, you can get a car. If you then R, you conclude if P, then R is true. All this syllogism. Lesson. The front of today's lesson, swing around into your quads, please. The front of today's lesson, swing around, face your quads. Start reading those paragraphs out loud. Rotate your readers, please. Okay, because if it's wrong, it's alrighty, because we're all in practice mode here. Okay, see. Melanie, Professor Jiang, etc. Is that deductive or inductive, ma'am, by your estimation? Deductive it is. And the reason the key word there was no, it starts with a truth, and applies it to a specific situation. So that is correct. That is deductive reasoning. Deductive reasoning. Okay. Hudson, Pythagoras, etc. What does your team think? Inductive. And the key thought there, see the word took measurements? That's the observed, aha, discovered truth. Inductive. I'm going to need 3 helpers here. Let's see. Andrew, tell me, what is your 3 numbers? Okay, I'll take a volunteer for this one. What is this called? It has a name. This numerical sequence actually has a name. It is a pattern. Might want to write this down, guys. We're going to cycle back this in Christmas. Fibonacci sequence. Okay, nod your head if you're like, I've at least heard that before. Okay. All righty, guys. And Emma, tell me, what's the pattern going on, ma'am? Right, you add the previous, so we added these guys and got that. Added these 2 and got that, etc. Good. Now, how many teams voted for inductive? Inductive. How many teams voted for deductive? Did anybody vote for both? Do you have a serious argument? Okay, remember, say discover truth. The process of discovering the aha, I get it. That's inductive. The using the truth to predict the future it's yes. And I set you up for that because I kept you the word or. Now, in geometry, the majority of the logic we use, the majority of the time, is going to be deductive. And that is because the truths we work with. But before I get into geometry, I'm going to recap what you're more familiar with, which are algebra. Can you please go back to this book? Go back to your reference booklet. Don't worry, this is not too confusing or painful. It's really simple, I promise. And that's not a math teacher trying to convince you it's simple when it's really, really hard. It's truly is simple. Ready? Lights, please, folks. We have different kinds of truth. Here's your first truth. You can do this in algebra. We are back on your reference booklet, right-hand side. Reference booklet, right-hand side. Oh. Okay, just so the very next step. What property is that called? Lovely. Here's another trick. I want you to go ahead and just box these 2 numbers together. You guys know that as collect or collect right term. The technical name, if you're adding or subtracting on one side of the equal sign, notice I'm only on one side here. That is called addition and subtraction of real numbers. I'd like you to go ahead and box this. Notice again, I'm on one side. So because I'm on one side, I can go ahead and divide stuff out. And because it's on one side, not to be confused with this. Now, only on one addition, subtraction, property. Addition, subtraction, property. I multiply both sides. I divide both sides. That's Multiplication, division, property. I've seen this before. That's why I'm starting with algebra truth. I'd like you to flip your books, please. Flip your books. Now you're looking at this. Right there. You have two fractions across an equal sign. You can do this. Right? Watch carefully. Notice I did not distribute. You never cross multiply and distribute in the same step. And down here, I have x squared equals 64. I'd like you to go to the don't do this circle. Ready? Go like this. Opposite of squaring. Again, opposite of squaring is square rooting. Again, up is x squared equals 64. We do one of these numbers, and we end up with x square root of 64 is a big fat 8. I'm going to write that down, folks. Yeah, see, you can rotate forward. You know, that might be easier than bouncing over your shoulders. The opposite of square rooting is squaring. The opposite of square rooting is squaring. So if I have root x equals 6, I do this, which technically is this, right? X times x, it looks like this. And since, because I'm square rooting a square, they just kind of cancel each other. So the opposite of square rooting is squaring. All right, substitution property, guys. This is the real hard one right here. If I have 3 times x and I define my x as that circle, substitute. What's going on with these? Ask yourself. Fill it out. Ask him. Okay, leave that where you can see it. Go back to today's lesson and go to page 3, please. Go back to today's lesson and go to page 3, please. Alrighty. In a math class, for literally almost a decade now, you have been focused on this one question word. What is the answer? What, way back, first grade, kindergarten, what's 2 plus 2? Later on, what's 30%? Whatever. Middle school, what's the value of x? And then you kind of go up. So what is the answer has been your main question you have focused on. Occasionally, you have a teacher that asks you how. Put how in the margin. I don't want to. So how many of you had a teacher that was barking at you all the time? Okay, great. You're going to go back to that teacher, or you are not physically around them. You are going to email them, and you're going to say thank you very much. Because if you have been trained, really have you been addressing the question, why? Why? Actually focus here. And that's why I'm starting with algebra, because you're used to it. In fact, about a month from now, I'm actually going to give you the answer. We're going to address this question. So let's do this together. Let me show you how I want this done. Ready? Follow. Now, you're looking in your reference booklet for what was the mathematical truth. What is the mathematical reason why? Yes, that is the reason why you can take that step. So we're going to be, whoop, that doesn't look like a D. That's better. Distributive property. Ready? Now, next line. You're going to underline your X's, circle your numbers. Ready? I like you to hunt down what is the mathematical reason that is acceptable. Don't say it out loud. What is the mathematical reason that? Miles, what do you think, sir? Okay, we did this. We called it that, but then I told you it had a technical name. So yes, you're kind of correct, Charles. Help him out just a bit. Yes, addition, subtraction of real numbers. You guys know it as collect-like terms, but I want you to use the technical name. Now, give me the reason why there. Yes, it would be. Good call, guys. What do you think? Yes, but we have a special name for that. Addition, subtraction. It's in your reference booklet, ma'am. It's not the real numbers one. Flip back to where we were. Flip it back over the other way. Flip there. Flip, flip, flip. There it is. You're close. Property. Addition and subtraction property. When you're canceling across both sides. Okay. Last but not least here, we're going to go divide by negative 18 to get x by itself. What's the reason why? You are ultimately, that's what we're doing, but let's be a little bit more specific here. Okay, what did we do to both sides? We divided both sides. What do we call that? Multiplication, division. Bam. There we go, folks. And that, my friends, is how you're doing math problems. Not only do you get what is about x, but I show you how, and now adding the y column. I think you got the hang of this, folks. So this problem right here, go ahead and I'll let you cross that one problem out. Yes, because I know crossing. Alrighty, guys. You are working on pages 4 through 8. You have 5 minutes. Go. Yes, sir. Hi, guys. Good luck. Stay safe.